thing.
Oh, stop thinking that. No, sorry.
And coming from a super duper, very rigorous military background, and is really one of the foremost leaders in remote viewing.
Thank you. I appreciate it. So full disclosure up front, I just finished this PowerPoint in the very recent past. So I may be as surprised as what turns up as you are. And of course, I have to first master the technology here too. This is forward, this is reverse, this is neutral. Oh, never mind. Okay, what makes scientific evidence scientific? Okay. So many of you have probably encountered skeptics and critics and people who are dubious about this, all the subject matter that we deal with here. And they will say there is no evidence for what you believe. Oftentimes, you do get some who actually believe that. Most of these are uninformed skeptics who actually haven't done any looking into the debate at all, much less surveyed what evidence there is. What most people who say this mean, though, is something along the lines of, there's no evidence that isn't controversial, or there's no evidence that I will accept, or there's no evidence that is scientifically respectable. Essentially, the evidence for ESP or whatever psi modality you want to consider, it just isn't scientific. So this is, of course, at root, a major component of the argument about demarcation. That is, how do you distinguish between science and pseudoscience? And no matter how hard they try, philosophers of science and mainstream scientists haven't successfully come up with a criteria that can divide those two out. And it's doubtful that they ever will, partly because, of course, that today's pseudoscience is tomorrow's science in many cases. So, recognizing that we have an issue with this, I was thinking about the fact that we don't have any specialized criteria for what counts as evidence. What's my next slide? Oh, yeah. So, we don't have a checklist of attributes that when we produce a set of evidence, we say, well, this evidence is scientific. And maybe another set of evidence isn't scientific. So what would be the value of having a checklist? Well, if you think about it, instead of having this criteria to determine what scientific evidence is, that is, we know it when we see it, and some of you may remember where that phrase comes from in the past. People say, well, it's not scientific evidence, but this is scientific evidence. Well, you say, well, okay, so what distinguishes one set of evidence from another? We can have, instead, a set of criteria against which we can assess the scientificity, don't look for that in a dictionary, the scientificity of a set of evidence that you might encounter. All right, so this is the set. Don't bother trying to capture this. I'm going to go through these in detail. But I have 7 suggestions here that I think would count as criteria against which you can assess evidence, determine whether it reaches the threshold of being scientific or not. So, but first, some preliminary details. First, the criteria I'm going to suggest are often already understood intuitively. You'll say, oh, yeah, obviously that's a criterion. You'll say that when you see it. Duh, I mean, why is he putting that up there? It's because it's never been actually codified or formalized as part of the criteria for what counts as scientific evidence. My list is perhaps, in fact, highly likely incomplete. Maybe there are better labels available than what I've used. Perhaps some of these don't really belong. And I'm open to suggestions, okay? If you have some thoughts about it, that'd be great. But I think that this exercise is necessary, and we really need to probably boil down to what is the essence of what counts as scientific when it comes to evidence. Okay, so first off, well, there's lots of first offs here. The next thing I want to talk about is the idea of how evidence fits into hypotheses and theories, right? Obviously, evidence is the kind of the foundation from which hypotheses and theories come, and then it actually serves as a validating device and a way of assessing a theory or a hypothesis and determining the truth value of it overall and refining it and you know the whole scientific process. But if you think about it, evidence is the core of all of that, right? So let's go through these criteria that I'm proposing. First one is what I call relevance. And roughly said, the more strongly and directly a set of evidence supports a hypothesis or some other claim you're making, the more confirmation it provides for that hypothesis. This is one of those duh things. Well, you know, if you're trying to determine that bacteria content of milk and you're measuring the temperature of the cow, probably is not going to make much difference. That evidence isn't going to be very helpful, right? But when you get right down to it, evaluating how relevant a piece of information is for a particular claim or hypothesis is actually the first step you do. That's an important thing. And the more relevant it is, the more it brings to bear against that claim. So the next one is independence. And what I mean by independence is, by the way, not all of these pictures are going to necessarily match. I couldn't figure out how you show independence other than an American flag with the guy blowing the flute, right? So here we have, you know, a different kind of a flower, but it's still a flower, right? So independence essentially is, it's evidence that presents stronger confirmation. So it comes as a result of a separate evidentiary claim, as opposed to some evidence that is kind of a piece with other kinds of evidence. The more independent it is of that particular of other evidence, the stronger it tells. Now, I was going to try and get through without saying consilience to prove to somebody I could, but I failed. So you might recognize this is kind of an element of consilience, at least in the lowercase c version of it, not the uppercase c of consilience, right? So let's see. This is something Elliot Sober, the philosopher of biology, philosopher of science, said. He said, if I examine two dependent effects, there is a higher probability that I will obtain relevant information. A match. Two dependent effects. There's a higher probability that I will get a match. However, if I examine the independent effects, but manage nonetheless to obtain a match, that information will be weightier than a match obtained on dependent effects. Okay? And then again, this is also kind of intuitive. If you get a separate piece of information that isn't dependent on the information you already have, that's going to be more confirmatory. Now, a real-world example, back when I was a wet behind the ears second lieutenant, I had an old crusty senior master sergeant who had done 4 tours in Vietnam, and he was telling a story about one of the problems they ran into, and that was that, of course, everybody's out there trying to collect intelligence against the Viet Cong or the North Vietnamese, whoever it might be, and each of these units were kind of independent of each other, and they weren't necessarily comparing notes. That was back before we had all this great integrative technology, which sometimes works, okay? So they had this Vietnamese source who would peddle information, right? He had some information, sometimes it was real, but usually it wasn't, and he'd go from each of these units, which were spread out over a particular region, and he would sell the same intelligence to each one of them. And then what had happened is, he had a different name. Each of them knew him by a different name. So they're all thinking, okay, there's all these different sources. We're getting the same confirmation about, you know, movements of the enemy or whatever. It must be really legitimate information. But he was making a great living at peddling the same information and pretending to be somebody different in each place. And consequently, a lot of bad decisions were made because the information really wasn't independent. Okay? And that we have to be careful that doesn't happen in science. Okay, what's next? Diversity, a very popular word today. And in some ways, it's kind of similar to how we meet it in society and culture. So, diversity, diverse evidence is more confirmatory than less diverse evidence. This is related to independence, but it's a little bit different. They kind of overlap. So, the more different sources you can get confirmatory evidence from, the more confirmatory it is, and therefore the more scientific it is, right? So this is something that a writer named Horowitz said. We think that theories are better confirmed by a broad spectrum of different kinds of evidence than by a narrow, repetitive set of data. Makes sense. This is also an element in lower C consilience as well. So how do you achieve diversity? That is, diversity between or among instances of items of evidence. So when you talk about diversity, you can't be talking about one element of evidence, because we're talking about some diversity implies multiple elements, right? So I in my writing about this, I call them evidences. I've added an S on it. Again, something you probably won't find in a dictionary. But so we're talking about comparing evidences here. So ways you can do it, maybe you can vary the properties that you're testing. You have maybe multiple independent investigators in a particular field, all of whom are working on the same project, but separately from each other. You may explore multiple phenomena that still nonetheless may have relevance to each other. You may vary the kinds of instrumentation you use to examine the phenomena. Okay. Example I have of that. So let's say you're working on an experiment to determine the refractory properties of some kind of translucent material to make sure they meet. You predict a certain thing about the refractory, I should have picked a word I could say better, refractory properties of this material. And there's a number of ways you can evaluate that. So one might be the angle at which you strike it with a light beam. Another might be, using different wavelengths of light, attempting different dispersion patterns with it, intensity of light, or other elements that are be different ways of testing the same material to come to achieve the outcome that the information that you're trying to achieve about it, right? So that's a version of diversity. Another one might be in the field of archaeology. You're trying to assess maybe the beliefs or practices of a certain culture, and there you might go for markings on pottery shards. How do you say it? I'm not an archaeologist. The stratification of different elements that you find in a dig. I have a whole laundry list of these, but you get the idea. There may be all kinds of different elements that you can bring together that have bearing on your question that may help you bring resolution, and those are all diverse elements that will make your conclusions more robust and more accurate. Okay, next one is repeatability. Okay, so repeatability. Evidence that can be reproduced by the creation of the same or closely similar circumstances in which that information was first observed in a repetitive way more strongly confirms a hypothesis than does a singular occurrence of such evidence. Okay, that's a no-brainer. If you have one instance of a phenomenon occurring under certain conditions, that's not enough to really tell you much. If you can repeat that, then of course you're making progress. You can certify that this outcome is not just a one-off fluke, but that it can be repeated. Now, this is also very obvious to us, except there's one thing I want to add to this, and that is repeatability isn't replicability. I'm going to go into that in a little bit. But in this case, repeatability applies whether it's the same lab doing the same experiment or multiple labs, no matter how many, doing the same or similar experiments. That all counts under the rubric of repeatability. Okay. So next is something I've called accordance. Accordance. Acceptable evidence must be produced in accordance with well-formed and scientifically trustworthy methods and techniques. Now, I don't know, you may recognize some of the folks in this photo, and if you want to approach me afterwards, I'll tell you what was going on here. But it did involve research into a phenomenon. It was quite interesting. Accordance, however, so essentially what I'm saying when I say accordance, what I'm talking about is, and this is kind of an expectation that people automatically have in scientific fields, is that when you produce evidence, that they can look at your methodology, they can look at your statistics, they can look at your analysis, they can look at your conclusions and say, okay, this fits within the framework of the process and conduct of standard accepted science. Okay, that would be accordance. But there are a couple of things to keep in mind that are important. First one is, accordance, in the way I mean it, doesn't require that new methods necessarily be consistent. No, it requires that they be consistent with current scientific practice, but it doesn't require they be the same. Otherwise, let's see, do I have a slide for this? Okay, they do not preclude new or novel methods or techniques or exploring divergent phenomenon because otherwise science couldn't progress. Okay? You have to allow room for people to explore and experiment beyond the bounds, but you have to use good judgment, beyond the bounds of what's normally accepted as science, as long as most of what they're doing fits within that context. Okay? So accordance is really important, and oftentimes that's all that people use to judge whether evidence is scientific or not. All right, it goes some way or other. That was a scientific experiment and I failed it. Okay. So the next one is publicity and objectivity. What I mean by this is evidence must be observable and reportable by anyone who can arrange to be in the right place at the right time under the right conditions and, if necessary, with the correct equipment. Okay. Now, I'm going to expand on that. First off, subjective evidence is still evidence. That's one of the mistakes that a lot of scientists make, is that, oh, that evidence is subjective, or that claim is subjective, or whatever. This kind of goes back to a little bit of what Imans was talking about. It's subjective. It doesn't count as evidence. It's not evidence. Well, that's false. It is evidence of a sort. It's just not as powerful in a scientific context as objective or public evidence is, okay? So I want to say, so the best evidence in science has to be available to science because they have to check it, test it, verify it, and apply it objectively in a public way, or you'll never know, you can't know just based on someone's subjective experience how legitimate or illegitimate that experience is that they report, okay? All right, so let's go to congruence. What's congruence? The more closely a piece of evidence can be accommodated without contradiction within an existing body of evidence that already supports a hypothesis or theory, the more strongly the new evidence confirms that hypothesis or theory. This is also an intuitive, fairly obvious thing. If you think about it, if somebody pops up with a piece of evidence that doesn't fit at all, maybe even contradicts the information you have, the first psychological inclination, and in fact the first legitimately scientific inclination, is to question that new piece of evidence. Okay? If it fits within your already existing theory base, then it's less questionable. It makes more sense because we understand it. This goes back to Willard von Orman Quine, I hope I spelled his name right because I was doing it from memory, who had this idea of the web of belief, where the idea you had a kind of a core of belief, set of knowledge, and the closer a piece of information came, or a piece of knowledge came to that core, the more readily we would accept it, and we would be more justified to accept it, the closer in. The further out on the fringes, that's where we start having to kind of, maybe the jury is out on something, withhold judgment on it, and examine it more carefully, more closely, before we are willing to admit it into our database, into our corpus of belief. And I just got the 3-minute warning. And that's kind of a football thing, isn't it? Okay. All right, so important points to consider. Not all of the criteria may apply to certain items of evidence. There are some kinds of evidence that you can't apply these to. In paleontology, for example, you aren't going to go and keep creating new evidence. You just have to find what you can find, and that's what you get, right? The more that can be applied of these criteria, the more we consider that evidence as scientific. But how, and these criteria can be used in the demarcation, and how the, I don't know what I meant by that, how these criteria can be used in the demarcation debate is when somebody claims that the evidence isn't scientific, then you can say, okay, well, why isn't it? Here's what counts as scientific evidence. Does it not meet these criteria? Okay, and so it helps us determine what might be scientific and what might not be. Okay, there are two concepts I didn't mention. One was falsifiability, one was replication, except briefly. So falsifiability, notoriously Karl Popper, who thought that astrology and psychoanalysis were equally valid sciences, which wasn't, okay? It's relevant to hypotheses and theories, but it's not concerned with evidence. It has only to do with the legitimacy of a hypothesis or a theory. Elements of replication. Replication is actually a composite. It's kind of a meta property of three that I mentioned. One is independence, one is repeatability, one is diversity. Those together constitute replication. And I don't have time to make the argument because I've already been told my time is exhausted, but I'm going to charge on anyway as quickly as I can. Okay, if we think these 7 criteria are definitive, does the evidence for psi meet these criteria? And I'm not going to give you an example of that because I don't have time for that. But if it does that mean it? If it is, what does that mean if it's still rejected? So if you get a critic who says, oh, I don't care if it meets those criteria, it's still not legitimate evidence. Well, then here's the problem. Makes us wonder, first of all, makes us wonder, does scientific evidence itself even count as scientific? Because if the criteria applies to scientific evidence, but they say, yes, there is this psi effect that we have the same criteria fit the evidence for that, but we reject that, what stops us from rejecting mainstream science evidence as well? So I guess I'll quit there. Oops, I'm not going to give you that example. I had a final slide. Let me find it. Oh, there it is right there. Thank you. Question and answer.
All right.
Well, I apologize in advance. My question is more related to the general topic than your specific talk. But I think in 1 minute or less, I think I have a solution to consilience. And it would be a very simple software solution, even though I started out as a critic of
Is it the blue screen of death that comes on everybody's computer? Is that it? No?
could be.
No? Okay.
So it's a crowdsourced software solution, and it would create an open and dynamic consilience mind map. You would start with a couple of dozen basic nodes, such as consciousness is primary, or neurological materialism is wrong, etc. And then SSE members would just sign on to this website, storing the mind map, and each node would have a slider control. Very important to be analog, not digital, because you want collaboration between right and left hemispheres. And the nodes that got higher ratings, you would be invited to do it very quickly, would get larger or otherwise indicate their heightened status, while less popular ones would get smaller or even voted off the mind map island. Those voted off the mind map would then go into a probationary area where they could be revived. And there would also be a candidate area of proposed nodes that could join the current mind map if they got enough support. In this way, there's no frozen ideology of consilience, but a dynamic crowdsourced map open to excision of what has become obsolete and to totally new nodes. The map would also track trends, which would be very interesting feedback. And users would also receive their individual consilience map based on their preferences, so they could see how congruent or not that is with the collective map.
Okay.
That's my solution.
Okay.
I'm going to try to repeat that from memory.
Yes. You just don't want to get voted off the consilience island is all, yeah.
So you had, at the beginning of your talk, said, hey, there may be others. And I wanted to propose something just for your consideration. You actually danced around this particular one several times in what you talked about, so you may argue that it's already in there.
Okay.
But the quality and extent of documentation of evidence is actually very important in establishing its scientific validity because you need to understand the context of what you do. So a lot of times we'll get evidence, and we'll say, and here it is, but we don't always document all the issues, I shouldn't say issues, but all the constraints and the context under which that evidence arose, which makes it unaccessible to anybody except for the original collector. So that's just something else that you can add to your list.
In a way that's related to publicity objectivity,
Oh,
but it's more like turning that into a record that anyone can examine. So I wrote it down here. I think that's a good suggestion. Okay.
I think we'll have to continue this discussion offline, but let's give a great thank you to Paul
Thank you.
for his insights.